Hello everyone. This video is intended to help you with some graphing calculations. There's another video that's about how to describe the motion based on graphs, but this is more about doing calculations. So we're going to start with the position time graph, and we are going to focus from 1 second to 6 seconds. I'm going to focus from right here, 1 second, all the way over to here, which is 6 seconds. And we're going to go through a series of different things, like, for example, the distance traveled. Okay, distance is, as we discussed in class, just the path length followed. Like, you just add up all the segments. Add all segments. So at 1 second, we're at +2. And then at 3 seconds, we go down to 0. So we've traveled 2 meters down. Then at 5 seconds over here, we've traveled another 2 meters down. And then at 6 seconds, we've gone another 1 meter back up. Okay, or in the positive direction, I should say. So we've traveled a total distance of 5 meters. That's it. I mean, it's literally, I went 2 meters plus 2 meters plus 1 meter is a total of 5 meters. However, displacement is different. And don't get me wrong, a lot of the year distance and displacement are the same. We talked about this in class. Distance is the actual path length followed, while displacement is just the final minus the initial position. Literally, delta D is the final minus the initial position. That's it. Doesn't matter what happens in between. Where did you start? Where did you end? Sorry, I was just double checking the time there to make sure it was really 6 seconds. All right, so the final position is 0 meters, and the initial position is +2 meters. So my displacement over that entire time is -2 meters. The difference here would be, like, you took a total of 5 steps, that's your distance, but you ended up 2 meters to the left of where you started. All right, and now if we wanted to calculate the average speed, average speed is simply distance over time. And in this case, it would be 5 meters over 5 seconds, giving us some seriously easy math. If you can't do this in your head, you need to let me know. We need to have a serious discussion. 1 meter per second. And then the average velocity is displacement over time. So that is delta D over delta T. The differences in this mostly arise between average speed and average velocity. They do tend to arrive a lot in graphs. And for much of the year, average speed or speed and velocity are like, they're very similar, but velocity, as you know, includes direction. All right, so in this case, it's -2 meters over 5 seconds, because that's 1 to 6 seconds for a total of 5 seconds, gives us -0.4 meters per second. So there's clearly a difference between average speed and average velocity. All right, let's take a look at the velocity time graph, and we'll go through the same things. As you are hopefully aware, we have an expression that is delta D equals V delta T. Distance equals velocity times time, or displacement equals velocity times time, depending on what we're doing. But either way, we're talking about velocity times time, literally the y-axis multiplied by the x-axis. And that's giving us the area. Okay, so we're taking the area of this graph. That's important. When it comes to velocity time graph, it is all about area. So let's do distance first. Distance is the absolute values of the areas. You add up areas. The absolute values. And let's go from, I don't know, 0 seconds to 6 seconds. So that's 0 to 6 seconds over here. So we're going to add up all these little areas. And it shows these numbers because they're really easy. 1/2 base times height. Each of this distance here is 1 second. So that's very easy. The height is 2 meters per second. So each of these areas at 1/2 base times height, I'll write it out here just in case, because it's a triangle. It's not always 1/2 base times height. If it's a rectangle, then just do base times height. Base is 1 second. Height is 2 meters per second. So each of these is 1 meter. So this is 1 meter, 1 meter. This area here is 1 meter, 1 meter. This area here is 1 meter. And again, by area, we are referring to the area between the line and the x-axis, like your graph line and your x-axis. All right, so adding up all those areas, that's super easy. Can you do that before I write it down? Can you do it in your head? I'm going to go with 5 meters. Hopefully I got that right. Now, displacement is different, sort of, because it includes direction. Includes direction, so you must just add the areas. So you're going to add areas. Do not take absolute value. Okay, just so going across the graph, we have positive 1 meter plus another 1 meter, but then we have negative areas. So minus 1 meter, negative 1 meter, and then we have another negative 1 meter. So we get a displacement of negative 1 meters. Again, it's kind of like saying I took 5 steps, but I only ended up 1 meter to the left of where I started. Okay, distance. This video will not be edited. Average speed is distance over time, which in this case would be the absolute value of the areas over time, or 5 meters over a total of 6 seconds gives us 0.833 meters per second. That's your average speed. And then your average velocity is displacement over time, because velocity includes direction. So this is just the area over the time, or areas depending. And in this case, it was negative 1 meter was our total over 6 seconds, or negative 0.167 meters per second. And by the way, I don't know if these graphs match the position time on the previous page and the velocity time on this page. They weren't meant to match. I just took them off of homework because I didn't feel like redoing them. I thought they looked pretty good. Anyway, I hope that helps with some of the differences in the calculations. As per usual, I have an excellent summary at the end of this video because, yeah, I'm that good. And if you were making videos by yourself in your kitchen, you would be talking nonsense too. So here's a summary. I mean, I don't know if you want me to go through it, but I will. It does everything that we just talked about. You know, in a position time graph, distance is just you add up all the individual distances. Displacement is the change in position. You don't care about what happens in between. It's just final minus initial. Speed is distance over time versus velocity, which is displacement over time. And the same thing goes true with the velocity time graph, except the velocity time graph, to get distance, we're talking about areas. So if we're getting distance, it's the absolute value of the areas. If it's displacement, include the negative area, include the sign. Speed, again, is distance over time, and velocity is displacement over time. So absolute value of area over time versus, positive, negative total area over time. In red here, I've also added, if you took the area of the acceleration versus time graph, you would actually get change in velocity. Since acceleration is delta v over delta t, and if you do the y-axis times the x-axis, or a delta t, you get delta v. This will probably rear its head more in AP than in Physics 1, but I wanted you to be aware. But other than that, I know graphing is super enthralling, just as this video was, so I hope it was helpful in some way, shape, or form, and it's a definite rock solid 3 out of 5 stars, and I would definitely not change anything about it.